Hey everybody, we've got a lab going today, and it should be a little bit more fun than what we usually do. It's called the percentage of oxygen in the atmosphere lab. In yesterday's notes, you should have seen that the atmosphere is made up of a mixture of gases, and the most prominent of those gases is nitrogen. And we breathe nitrogen in, and we breathe it right back out. It does us no good or no harm. But the second most abundant gas in the atmosphere is oxygen. And what we want to do today is figure out how much oxygen is in the atmosphere. So we have a neat little lab where we can do that. So read along as I read it here. It says the atmosphere of the Earth is composed of a mixture of gases. The two most abundant are nitrogen and oxygen. In this investigation, we're going to measure the amount of air consumed during the combustion by measuring the volume of gas before and after. Since nitrogen is not combustible or consumable, and oxygen is, we're able to calculate the percentage of oxygen present in the atmosphere. So we're trying to answer the question, hey, what's the percentage of oxygen in Earth's atmosphere? These are the materials we'll be using. Okay, and here's our procedure, and this is what I wanted to go over. So I'll be doing this, and you'll just be watching it and recording some numbers in a chart. But here's what we're going to do. We're going to fill a beaker, a 100 milliliter beaker, up to the very rim, and then we're going to pour it into a 100 milliliter graduated cylinder. You might think it's going to be 100 milliliters since it's a 100 milliliter beaker, but it actually fits more water. So what I'm going to do is fill it up to 100 milliliter level, dump that water out, and then I'll fill with the graduated cylinder with the remaining water from the beaker, and I'll add the two. So it'll be 100 plus whatever the second reading is. And you're going to put that total in the total air in beaker. So of course we're putting water in there so we can measure it, but what that represents is the amount of water that, the amount of air that's in that beaker. Okay, and you're going to record that in the table. And that table is part of an Excel file. You'll just pull it up. It'll be one of the resources. Once we've figured out how much air is in that beaker, we're going to put some water in a petri dish. We're going to put a candle in it. I'll light the candle, and then I'm going to put a beaker upside down over the candle. And the candle will continue to burn until all the oxygen's used. And then you're going to see that the water is sucked up or actually pressed into the beaker. And we will make a marking at the water level. Okay. And then what we're going to do is fill the beaker to that water level and then pour it into the 100 milliliter graduated cylinder to figure out how much air is still in that beaker. And we will record that in the table in the air remaining row. Okay, we're going to do the same thing 2 times over, so for a total of 3 trials. Once you do that, it tells you to subtract the amount and calculate, but I've set up the data table so it'll do it for you. Just make sure you're only filling out the yellow spots or yellow cells on the table. Don't mess around with the black cells. The black cells will change as you add stuff into the yellow cells. All right, so here we go. I'll be right back with some other videos.